to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Ledfakinetti, and let's write some code together, shall we? What we have on the menu today is my personal nightmare. We are going to continue working with parameters. Oh my God. In case you are new here, we have been developing real-time audio effects in JSFX, the programming language that exists in REAPER. We are in the process of developing a library as well as a series of effects. Mostly right now, we are concentrating on the problem of parameters and how to manage them. Parameters being things like threshold, attack and release, volume, that kind of thing. These parameters exist in several different places in a plugin, and you have to sometimes sync, sometimes you have to compute derived parameters. It's a whole thing. We'll continue working on this today. We will see the finish line, perhaps, hopefully. But before we get into the code, hello, Mage, and hello, Tail. How are you all doing? Long time no see, Tail. What have you been up to? Okay, let's dive to the code. Let's dive into the code. I will not reiterate the whole context of how we got here. If you have questions, then ask on the chat and I will do my best job to answer, but there is a lot of context going on, and if you are brand new to these streams, you may need to ask questions on the chat, or you may need to rewatch some of the older streams to understand how we got here. Anyhow, we have this concept of linking parameters across plugin instances, which will be necessary for the auto mixer. And to allow the different plugin instances to communicate, we use the global memory. So these are addresses into the global memory. That's one place where parameters appear. There is also the slider. Then there is the user interface. And then there are derived parameters from the parameters. These tend to be used in the audio processing itself, and these are just for the user controls. So there you have it, 4 places where parameters appear, and we are trying to make sense of them. And last time we came up with this function, well, last time we tweaked this function, and I even tweaked it some more after the stream last time. And today we are going to try and see if this works, but maybe we'll not even get into this function actually, because I was thinking of something else, which is this. Well, the job of this function is mostly to sync these parameters in the 4 different places I mentioned, compute the derived parameters and whatnot. This is a function that typically would be a section of code in JSFX, but it turns out that we want to run this function, or we want to run this block of code from different places for different reasons. So that's why I extracted this into a function. So let's go over all the places where we need to reason about parameters and how to sync them. First, when we are just starting up the plugin, we need to reason about sliders or parameters. because we may need to either initialize the global memory to make the linked parameters work, which is what we are doing by calling this function here, or vice versa. In some cases, we will want to take what is in the global memory and assign to the slider in the effect. And that is the case when you already have the global memory initialized, because there are some plugins that already exist and you are loading a new plugin. That new plugin needs to pick up the values from the global memory, needs to pick up the values from the other instances. So that's the init section. Then on the slider section, this is going to run when you automate, when you put some LFO on a parameter, or even when you have a JSFX honest to goodness slider on the screen. I guess it's time for me to start showing things. So if you just have a slider like this and you move it around, that calls the slider section, which calls the slider function. So that's call number 2. In the init section, there is one. On the slider section, there is another. Then this is not doing anything. That's not doing anything in terms of parameters. Then in the sample section, we call this function, and that is because the parameter may have changed every sample. If you have automation on something, the parameter will have changed on every sample. And then the linked parameters need to pick up this change. And it needs to do that in a sample accurate way. And that's why the slider function is being called on the sample block. That may be not the best idea because this function can be expensive and this is going to run often. But I couldn't think of anything else to do about this, so there is that. And then in the GFX block, you may be dealing with some custom user inputs. And in that case, you will be changing the value of the sliders programmatically, like we do here. And in that case, you call the slider function again to recompute derived parameters, sync stuff with the global memory and whatnot. Now, the crux of the issue that we haven't thought about before, but haven't really done anything about it, the crux of the issue is that you have to call the slider function from the sample block and you have to call the slider function from the GFX block. Because either you are doing on the GFX block some custom sliders like this, and you have to update stuff, or because the plugin needs to pick up changes from linked parameters from other instances on every sample. So these two calls need to occur. Now the problem is that the sample section and the GFX section run in parallel, so there is a bit of a race condition. It could be the case. Let's look at this parameter, which is linked. It could be the case that we call that we are, it's complicated to explain race conditions because it's complicated to understand race conditions. Let's look at the slider function, which is called in the sample block, the sample section of code. And that will write to, the GFX section will write to this variable, and this will write to that variable as well. So I guess the race condition goes like this. The GFX section writes to this variable a new value because you are dragging and dropping. So it writes a new value to this. Then the sample section gets in here. It says, are these two values the same? No, they are not. Oh, I guess I may have fixed the race condition then, because then this is not going to run, because these two variables are not the same. In fact, I have to be very careful about this and do it like that. Yeah, I was tweaking this code with this idea in mind, but I haven't really reached the bottom of it, but it seems to me as though I may have fixed the problem. That would be surprising. So in the JSFX section, you write a new value to this variable. Then the sample section gets in here and it says, are these two the same? They are not, because this has changed. It also has changed over here. So in that case, don't sync the global stuff to here. Cool. And that runs this, which is true in this case. Attack in MS is not the same as the previous value. And that will write to the global memory and then write to previous in such a way that even if for whatever reason you get into this state where attack MS... No. Yeah. I have to be careful about the order in which I do these updates, but if I update the global memory first, it means that the latest value will be in the global memory by the time that this is updated. So whatever race conditions may arise will be prevented by this check. I think we got this. Oh, that would be awesome. There is another problem though. The problem is that this call to slider and this call to slider, so in the JSFX section and in the sample section, they both can run in parallel. So it could be the case that you would get into this section with attack MS different from attack previous, which means that it would get into this section twice. And this section is idempotent, so that's okay. It is even re-entrant, which is even more okay. And what I'm saying with these fancy words is just, it doesn't matter if you run this section over and over and over, the result will always be the same. At least for these kinds of derived parameters that we have here. And most derived parameters are like that. Given the same inputs, they will give you the same parameters. And if they don't, it doesn't really matter all that much because you're just getting new random values, so to speak. But it is a bit of a waste of effort to go in here every time. So I was thinking before I started the stream about this whole strategy to make sure that the slider section could only be called from one place at a time. And then there would need to be some collaboration between the sample section and the JSFX section. And they would have to set flags and read flags and just call slider once. And the JSFX section would need to check if the effect is bypassed and the sample section is not even running a whole mess. But it seems as though this may work. We'll see. We'll go over all the 8 workflows that we could think about, and then we'll see if everything works, and then we'll test stuff for real in REAPER and everything. And if the solution is a simple check like that, I will be amazed. Let's see what you all have to say. Jazz is here. Hello. In Juice, I just use the inverse of block size as memory coefficient to delay the movement of slider. Works perfectly. You use the inverse of block size. So I guess that would be 1 over samples block or something. I forget the name of this variable. To delay the movement of slider. Oh, I think you're talking about sample accurate automation, aren't you? Because I think that in Juice, not sure about this, but I think that in Juice, you receive the movements of the parameters as a block. So I think it works like MIDI, where you receive a block, right? In Juice, you don't have the sample section, you only have the block section. And in there, you will receive events like at sample 23 in this block, there will be a movement of this parameter from here to there. And then at sample 65 into the block, there will be another movement of the parameter like that. So, and then this would make sense. Is this what you're talking about? This would be like the steps within the block. Is this what you're talking about? And Bo is here. Hello. I was wondering where you've been. Narrow. Hello. I saw your oscilloscope video and was confused how the display was moving left to right. Which oscilloscope video? The video in which I show my actual oscilloscope that I bought? Probably not. Probably one of my waveform display videos. And you were confused how the display was moving from left to right? Are you talking perhaps about my waveform display, which looks like this? It is moving, I would say, from right to left. But I'm not sure if your question has to do with this at all. So can you elaborate? Can you explain me the first one? The first one, watch. I probably said two things and you're referring to the first. Can you be more explicit? What a waveforms moving left to right? Oh, so what is the question exactly? Would you like for waveforms to move from left to right? It is possible to change the orientation of this plugin to go from horizontal to vertical. So we already have this notion of being able to move where things start and end, but I didn't bother implementing something that goes from left to right because I'm not sure how useful that would be, but in most cases things go from right to left like that. Does this make sense? Sorry, was listening while answering a question on the Obsidian forum. Fair enough. Yeah, you're interested in waveforms moving left to right. Interesting. Okay. Yeah, formatting on YouTube comments is a bit tricky, but let's format what you have here and make sense of it. You keep track of the previous parameters like we are doing, and that seems to be necessary to determine which parameters have changed. So I guess that's a necessary evil. I'm not in love with the fact that we need to keep track of this, but it is what it is. It's the only way of knowing what changed. And then you receive the parameter input. That's something that we don't have to be explicit about in JSFX. We are given this variable and it will be changed for us by the environment. But it is true that in Juice, as far as I remember, you have to be more explicit about this and you have to link parameters on the user interface with the internal variables, usually the member variables of your audio processor. You have to do that work yourself. Then the parameter increment. Oh, I see what you're doing. I see what you're doing. So you are taking an increment, which will be the place where you would like to be and the place where you are right now. You take the difference of that. So how do I get from where I am to where I want to be? And I want to do that not in one giant step. I want to do that in smaller steps. So you are smoothing the difference between where you are and where you want to be. In other words, you are smoothing the change of parameters, which is necessary for things like volume. If you jump from minus 18 to 0, you will hear a click because the volume will change too fast, which will distort the waveform. And what you're doing is you're smoothing this with respect to the block size. So if you change the block size, which is something that the user can do, they can come to the settings and change the block size over here. If you change the block size, it will change the smoothing. If your block size is too large, the parameter smoothing will probably take a long time, and that may be noticeable. So if your block size is ridiculously large, like 4096, and if your parameter in question is volume, for instance, and you're trying to prevent clicks in the audio, I think that if your block size is too large, you may be able to hear the volume ramping up. I have never experienced this. I have never tested this myself. It's just an intuition that I have. But yeah, we have talked about parameter smoothing a whole lot before, and we do have a solution for this, which is not this. This is the solution that I found in almost every JSFX. And by the way, this whole conversation, I don't think is exactly related to what we are doing here with the syncing of global parameters, but I may be wrong, or maybe I'm misunderstanding the whole point you're making. Anyway, so we had this conversation before, and I thought about this problem. Oh, if you change the block size, the output of the audio will not be the same, which I don't think is ideal. I think that the block size should only be about performance and latency, that trade-off, but it should not affect what you hear. And in this case, it does. Maybe I'm wrong with having this ideal in the first place, that the block size should not affect the sonic results, but I don't think it should. So the solution we came up with is different. It does not rely on the block size. It relies on limiting the amount of change. So you still keep track of where you are and where you want to be, but you don't allow yourself to take steps that are larger than an arbitrary given number. And that number needs to be calibrated. So for instance, for volume, you would want something that is so fast that you don't hear a volume ramping up, you don't hear a fade, but you want it to be so slow that you don't hear a click either. And then you have to fine tune that. We did that for volume and we fine tuned that parameter and it worked well. But in that case, the step that you take at each sample is not related to the block size. It is related to the sampling rate, but that's a different story. If you change the sampling rate, you have to change that parameter as well. So you have to calibrate that parameter with respect to the sampling rate. But that's a different conversation. But since we are limiting the rate of change, the slew rate, as some people would say, because we are changing the slew rate, that is independent of the block size. And I think that that is a better strategy for smoothing out parameters like volume. And anyway, here is the for loop where you are looping over samples, probably, and then you increment with that little number. And then the new parameter which can be used to achieve better results. Yeah, so I guess your implementation uses this increment, which is based on the block size. My implementation is a bit different. It kind of works like this. So you are taking this clip function that I made, but what it does is you are trying to get there, but you're going to clip this value. You're going to limit this value to an arbitrary number that needs to be calibrated. So in other words, you are taking steps towards where you want to be, but these steps need to be relatively small. So if you go from minus 18 to minus 18 dB to 0 dB, you will not hear a click, you will not hear a ramp, regardless of your block size, because this is a value that is independent of the block size, if that makes sense. Something like this, yeah, no problem with the messiness. I tried to fix it. Hope that conversation makes sense. Narrow says, how are the waveforms moving left to right. How are the waveforms are moving from left to right? You mean on this plugin? The waveforms are moving from right to left. Not sure what you mean. But in any case, how are the waveform, the samples moving in here? It's a circular buffer. The implementation for this took me months to get right. But yeah, it is a circular buffer. And when drawing, I traverse the circular buffer. And a circular buffer is just a chunk of memory that you traverse, let's say, from left to right. But when you get to the end, you start on the left again. So that's how this works. It's a circular buffer that is filled in with samples in the sample section and read by the GFX section. Mage says, being reading through the release notes of the past 2 years of TypeScript versions. Yeah, it is like starting to watch a TV show in season 11. That's what it feels like to be in the JavaScript community these days. Or I guess to join the JavaScript community these days. Because there is so much history. And you have to understand some of it or most of it to make sense of anything. Yeah, what I did when I started with TypeScript is I read the handbook, which is great. I also found 1 or 2 other books online, but they were not so good. The handbook was great. It gives you almost everything you need to get your bearings and start stuff. And then after using TypeScript, when a new version comes out, I read the release notes. So I guess I have read the 2 years that you're talking about, probably even more. But I haven't read them in one sitting. That is probably going to be a lot. And the other thing is there are many things that are only in the release notes. You don't find it on the handbook. You don't find it anywhere else. So you have to be watching the show for a while to make sense of things. Jazz says, but also for Juice, the block size is predefined by your process. What? Really? You're telling me that in Reaper, I can set a block size of 256, and in Juice, I could declare that I want a block size that is bigger or smaller than that? Is this what you're saying? Are you sure? I don't know Juice all that well. I'm still learning. And if you're interested in learning, we have a study group. Join us. Go to Discord. The link is on the description. Anyway, you're telling me that you can change the block size in Juice independently of the block size of the DAW? That is crazy to me. If that's the case, then yeah, you can set a block size and then you can do this increment stuff and it will be the same because you're in control of the block size. I know for a fact that in JSFX, that's very much not the case. In JSFX, we are given a block size that is the Reaper block size, the host block size, and we don't get control over that. The host is in control of that. Isn't clip just clamp? Yeah. Or is it also defining the precision of floating point values? No, it's just clamping. I can show you the implementation. That's the implementation. It's probably going to seem familiar to you. Right? You just make sure that a value is within the bounds. And if given only 2 parameters, the bounds are just negative that number and that number. Hope this makes sense. But yeah, it's not affecting the precision of floating point. And in fact, in JSFX, we don't have control over that. We only have one type of floating point number. In C++, you have your floats and your doubles and whatnot. In JSFX, everything is a double, no control over that. And I guess we could truncate things and control the precision in that way, but I'm not doing any of that. I was up to date before then, 2 years of Rust and fell behind. Yeah, I'm 6 years behind on the C++ curve. Fair enough. Oh, for your internal computation and not the juice process itself. But the problem is, well, I guess it's not a problem really. But you are going to receive stuff from the host in the block size given by the host. So in this case, 256. And if you wanted internally, you could chunk this into 64 samples or 512 or some number that is not even a power of 2. And I do get why that could be useful, because sometimes you're doing an FFT and you would like the window of the FFT to be 1024 samples, no matter what is the block size of the host. So if you have 256 samples of block size on the host, you just accumulate 4 of this. You just accumulate 4 of this, and then you have your 1024 samples of your block size, and then you can do your FFT. And conversely, if your host has a block size of 2056, then you can do 2 FFTs for every block that comes in. So I guess you can reblock stuff, so to speak. Not sure if this is something that I would like to do to solve a problem such as this. But yeah, that makes more sense to me. Yeah, for example, if you have your own DSP process. Yeah, an example being the discrete Fourier transform, the FFT. That's a case where you probably want to have a block size that is independent of the host block size. But while I think it's useful for something like an FFT, I don't think it's too heavy of a hammer for this problem, I would say. And then, yeah, I guess this block size is not the host block size, it's your internal block size. So at that point, this number is kind of arbitrary, isn't it? You're just saying that you are going from here to there in a certain window. You will take, let's say, 0.1 milliseconds to do this ramp. And it's going to be 0.1 milliseconds no matter what is the block size of the host and no matter what is the sampling rate, no matter any of that. Because you determined it for this parameter, a ramp of 0.1 milliseconds gives you good results. No clicks, no fades in volume. And I'm okay with that. I think that makes sense. How about use this, but not with block size? Yeah, I guess I agree with that idea, the 0.1 milliseconds I just explained. And that's actually an interesting thing. I think that at some point we will need different notions of smoothing, because I think that the slew rate notion that I have is useful in some parameters, and I think that your time-based notion is also useful in other parameters. Because with my slew rate solution, if you ramp from -200 to 0 dB, then I'm thinking of the most basic parameter here, volume. But if you're ramping this parameter from -200 to 0, then my slew rate may be too slow to catch up, while your time-based solution may be better. But then it may go so fast that it clicks. But then again, you are going from -200 to 0, so that difference is so drastic that any clicks would be masked anyway. So I'm not saying that this is the be-all and all solution. The slew rate limiting may not be ideal. That's what I'm doing now. I understand that maybe the time-based solution is better, and that's why everyone else uses it. Maybe I should be using it too. Let's go over this. These are the 8 workflows, the 8 operations that can happen in a plugin. Let's work through the details and see if the parameters are behaving like we wanted. First, what happens when the first instance of the plugin is loaded into a track? We have saved everything. We'll take the template and drop it on a track. In that case, what happens is we should get this default value. Let's work through the init section and see how that works. So we will initialize these 2 variables to undefined. The previous values are undefined. Then, is the memory initialized, the global memory? the side channel used to communicate between plugin instances, is that initialized? No, it's not. To begin with, every variable in JSFX is 0. So this is a 0 right now. So we skip over this. Then we will call the slider function. And that will set, well, this will be different because volume dB to begin with is 0, and that is undefined. So it will compute the derived parameters and it will set the previous value. That's correct. What happens to the side channel, the communication between plugin instances, the global memory? Well, in that case, that is not equal. So we skip over this, which is great because we don't want to overwrite this with a 0 that exists in memory right now. And this holds because that is 5 and that is undefined. So we will compute the derived parameters and we will write stuff into the global memory. And then later we'll say that the global memory has been initialized. That checks out. That's exactly what we want. And then from then on, everything should work out. But let's give this a quick read. So in this slider function, the second time it's called, for instance, from here and then from there and from there as well. In all those cases, the attack and the previous attack will be the same because it has been set here. So they will be the same. And in that case, I can read from global memory, which is a no-op in this case, because the global memory is what we just put in there. Well, it's not a no-op. It's still going to read, but it's going to give us the same value. So this will not trigger. And that's fine. We will move on to the next line without messing with any variable. Great. So that's workflow number 1. What happens when you load subsequent instances of the plugin? So I will change some of the sliders and I will load the plugin into a second track. And what happens here is what I would like to have happen. This has not picked up the default for this slider. It has synced with the other instance. Great. Let's work through the code and see how that happened. In this case, it's running the init section, but gmem has been initialized. So this variable is changed. It reads from the global memory. I think that that's it. I think that this is correct. If this memory has been initialized, then change the value of this slider to read from global memory. Great. I'm thinking if there is some kind of trick, because this line appears here as well. I'm thinking if there is some kind of trick I could play to try and force this line to run. And if I can force this line to run, I wonder if I should do that trick. I think that there is one trick I could play. I can check, is the memory initialized? If so, I can set this to undefined. Which is kind of cute. I'm saying that if the global memory has been initialized, then take the default from this slider and just pretend that it doesn't exist. Set it to undefined. And now the previous and the current are both undefined. So they're equal. When we get there, we overwrite this just like we wanted, reading from global memory. And then this line runs and updates global memory and whatnot. That seems very cute. Let's see if it still works, because we tested and it worked, but I changed the code, so let's test it again. So that's the first instance, and then we drop the effect on the second and the second track, and yeah, it synced. And then if I move the slider, the other one moves as well. If I change it from the user interface, it moves as well. And this slider can actually stand for LFOs, parameter automation on the track envelopes and whatnot. So all seems to check out. I like this solution. It's kind of cute. And it doesn't force you to read from this over and over. Nice. So that's workflow number 2. Let's see what people are saying. Mage is saying, Leandro thinks time passes. There are different kinds of streams. There are streams in which I know what I'm doing. I have done my research a whole lot before, and I have implemented the thing that I'm going to implement on the stream before. That happens often, actually. That I am re-implementing something or just adapting something that I already know very well how it works. For instance, the most recent example of this is the stream in which I implemented cramped and decramped filters because of the whole Dan Worrell-Harrison controversy. I have implemented cramped and decramped filters before. I knew what I was doing. The code went pretty okay. I mean, I think everything worked first or second try. I like those streams because I can convey some interesting and cool ideas, and I can hopefully show people how tricky concepts work. But then there is another kind of stream, which is what I'm doing today, for instance, where I don't know the solution already. I'm exploring the problem. And I find that very useful to explore the problem with you all, because you sometimes have great ideas. Often you have great ideas that help me along the way. And I just think that exploring problems is interesting. Trying all the wrong ideas together is valuable. I like doing that. But that means that sometimes, yes, I am staring at the screen, just thinking, is what I'm doing the right thing to do? And I have had one person in the past comment in one stream, just one person saying, like, dude, learn what you're going to show before you try and show it. Because they were watching this second type of stream and they were looking for the first kind of stream, I guess. How about not using conditions in all of the statement, but run it only once if, like, okay, let me format that. Okay, I see what you mean. So this is a style that, for instance, we use here. We want to make sure that this function, which is the entry point from our library into the JSFX section of the code that uses the library, there is some stuff that always needs to happen on every frame, this stuff down here, but there is stuff that we need to initialize. And we need to initialize that on the JSFX section because some variables are not defined in other sections of code. So we need to initialize this. We want this to run only once. So we want this to be like an init section for the JSFX section, if that makes any sense. And then we have this pattern. We check, have we initialized already? Or actually, do we need to initialize? If we need to initialize, then we set that need to initialize to false and initialize. So this runs only once. So what you're proposing is similar to that. And I guess that's similar to what's happening here. So I guess if we had a second parameter that is also linked, we could put it under here as well. I hope that that makes sense to you. But yeah, I agree. We can do all this in one step. We don't have to keep checking if the thing is initialized over and over. Good. Workflow number 3. We are changing this slider here. We are moving this slider, and we want the other one to come with. And there is a way to go to parameter linking here, and in Reaper you can link parameters, but this is even nicer than that, because this linking that we did with the global memory is bidirectional. With the Reaper parameter linking, it only works in one direction. You link this parameter to that parameter, so then you change that parameter, and this one changes with the other one. But the thing we have is you can change any parameter and the other is going to come with. Cool. How does that work? Well, the slider section we'll call the slider function, which will do the... It will do this. And this will set the global memory. The other plugin instance will have this hold. So it will read from global memory, and this will hold, and then it will compute the derived parameters and whatnot. Awesome. Workflow number 4, you're changing the parameter with the JSFX slider. It's a fake slider that we built using custom drawing functions. And that seems to be holding up as well. Nice. The way that that works is we set the slider. This variable is the slider variable. And then we call the slider function. So this is working for the same reason that that was working, which is great news. That's exactly what we want. We want one explanation for multiple workflows. 5. Workflow number 5, programmatic change to parameter. So that's the case when you have, like, I guess, linked parameters. That's an example of programmatic change. You may have, like in limiter 3 by toucan, where you enable the maximizer and these two parameters are linked, they move together. So that is a programmatic change. And the way that that is going to work is just pretty much the same thing we did here. So that is yet another workflow that can be explained with the same explanation. Great news. Workflow number 6, the syncing of parameters. I guess we explored that already. Workflow number 7, that is the tricky one. We're going to save the project and reopen the project. So on track 2, we have the volume all the way up, and on track 1, we have the volume all the way down. And the parameter that is linked has a value of 8 in both instances, just like that. Let's save the project to the temporary folder, and we will create a subdirectory for the project, and we'll call this 1. Then we'll close Reaper, reopen Reaper, recent projects 1, and check if, yeah, all the way down and 8, all the way up and 8. Awesome. How did that work? The sliders are stored in the Reaper project. So when the first instance, and we don't know which, one of these two was first. Anytime you load the project, Reaper will instantiate the plugins, and I don't think there is any guarantee as to which instance will run first. So one of these two ran first. The memory was not initialized, so this line did not run. Then this call occurred. This function got called. This was not the case because this was in the Reaper project, but that was undefined. So that was not the case. That didn't run. This ran, however, and set the global memory. and set the global memory to initialized. Then the second instance ran. The second instance saw that the global memory was initialized, discarded its own thing that was stored in the REAPER project but was just discarded, and picked it up from global memory. Awesome. Alternatively, the second instance may start and it may make progress into the init section, while the first instance has not set this. The effect of that is that it will see the memory as uninitialized, and it will too initialize the memory. So it will too run this line. But that's okay, because ideally these two values were linked to begin with, so they have the same values, so overwriting this over and over and over is idempotent. Awesome. So save and close, open and restore, those are the 7th and 8th workflows. We checked everything. I think that this approach holds water. I think we did it. Oh my God, I cannot believe it. This was the key, I think. And the interesting thing is that I got to this without even thinking that this is going to be the key. So I guess the key to solving all the concurrency problems is to keep track of the previous stage and only read stuff from global memory if our own internal notion has stabilized. If we have seen that notion twice in a row, then we can say, okay, I have stabilized. Now I will read from global memory. So there is no chance of me being overwritten, which is a problem that I described to great lengths in previous streams. Awesome. Oh my God. Jazz says, JavaScript is so cool after C++ and Python. It's my favorite. Seems like you can do everything with it, even if computation isn't as fast as some other low-level languages. True. It is faster than Python, though. Well, I guess it depends. Python can be very fast, but only because many people spend a lot of time doing C and C++ extensions for Python. So matplotlib and not matplotlib, NumPy and that kind of thing is written in C and C++, I think. So if you are doing that, you can do the same in JavaScript. You can pull stuff from C++ into JavaScript. But other than that, I think that if you're writing pure JavaScript and pure Python, I think that JavaScript is faster, isn't it? Programming language benchmark. Is that still a thing? It used to be a thing, and then they changed the website and everything. Fastest means lowest CPU seconds or elapsed seconds. No, I'm just interested in the language. JavaScript versus... Can I do JavaScript versus Python? Versus Java. So if I change... No, JavaScript versus C++. And then change this. No, it doesn't work like that. It used to be that this website was a great way of comparing the performance of languages in different benchmarks. These are very small programs, but they exercise some neat aspects of the language. But then they changed the website, and now I find it very hard to use. What if I do it the other way around? Python versus JavaScript. Oh, there you go. What's the fastest? Python 3 versus Node.js. I think that lower is better. Probably. Yeah, but this difference is enormous. And the memory in Python is about the same See, yeah, this doesn't make sense to me anymore. It used to be that this website was so good and they made it better and now it's worse. Or at least it is for me. I don't understand how to read this. I think that they used to have graphs and everything. They improved it and now I cannot use it anymore. I'm dumb. I'm silly. Whatever. Yeah, I do like JavaScript a whole lot. It's a great language. I use it all the time. I use it on my day job. I use it on side projects. I really like the ecosystem and I like the language itself as well. And I liked that when you write JavaScript, even people who don't like or don't read JavaScript that well can understand what you're writing. Maybe if you're using promises, not so much, but if you're writing the basic syntax of JavaScript, it is like a lingua franca of sorts. So when I'm trying to explain something to someone, I tend to resort to JavaScript if that's a possibility. Okay, but using that param compensation is not similar to actual gain compensation. Some people think after a distortion, if you pull the volume down, it's just gain compensating, but it's not. You have to compensate for the whole perceived loudness. What? Not sure what you mean by this. You have to compensate for whole perceived loudness. True, but we are not dealing with parameter with compensating any volume, are we? Not sure what you're talking about. JSFX is EL2 rather than JavaScript. Oh, right. So that's why you're talking about JavaScript. Not because I sometimes have JavaScript live streams like yesterday and 3 days ago. I was talking about JavaScript. You're talking about JavaScript because you think that JSFX is JavaScript. It is not. It is Jesus Sonic. When I first learned about JSFX, I was super psyched because I thought, yeah, I will be able to write audio processing in JavaScript. That sounds like the dream. Of course, with most JavaScript engines that have a garbage collector, it is not ideal for real-time processing of audio. So you tend not to use JavaScript for audio processing for this reason, because most engines have a garbage collector. But it's not an intrinsic property of the language. It's just the way that most interpreters and compilers for JavaScript work. They tend to have a runtime with a garbage collector, but they could have not. They could dispose of the garbage collector, and that would be great. But yeah, no. JSFX is Jesus Sonic for interesting reasons that I will not get into. You have to compensate for the perceived loudness, blah, blah, blah. I already read that. But is Python really faster or more fun if you spend all day trying to mimic a fraction of C++ speed if you could also just use C++ directly? Well, I think that there is more than just the technical aspects and performance when it comes to a language. There is also and perhaps even more importantly, the ecosystem, the packages, the text editors, compilers, how good are the error messages, how good are the docs. That's an important part. Do you get along with the other people who use the language? That's essential. Do you like talking to these people, collaborating with them on GitHub? Or maybe you are in an ecosystem that doesn't do open source all that much, but do you like the other people? Do you get along with the other people? I think that programming language is as much about culture as it is about the technical aspects. And that's why I dislike bad-mouthing other programming languages that I don't like, that personally, that I don't use myself. I think that criticizing programming languages it's like criticizing natural languages. You don't say that the language of that people is better or worse because it can express certain ideas better or less well. Anyway, Python is really good for data sets and natural networks. And I think I know why. And I agree with you. And I think that Python is really good for these things because these are the things that people started using Python for. So in education and universities, they started to use Python because Python had some libraries that would help teaching. and the syntax would also help with that. So that became the language that people learn in university, and then they get out of university and into industry, and then get to work in big data, and they get to work in artificial intelligence and so on. So then they carry the language that they know, and then they build libraries for that, and then the language becomes even better for these tasks. So it's a self-reinforcing cycle. So I have a theory. I agree with this, and I have this theory that it is the language that is good for these things because it is the language that people use for these things. And also because it has lots of development which has gone into since recent years. Yeah. Oh, okay. So we already knew about this whole JSFX is not JavaScript. But talking about web audio, yeah, web audio is interesting. The platform is interesting. It is limited in some ways precisely for the reason I explained. JavaScript in the browser is garbage collected. You don't want a garbage collector when doing real-time audio processing. So the way that the web audio API people found around this is interesting. They sort of limit you in some ways. You have a couple oscillators and that sort of thing, but you don't get to do the low-level sample processing that we do in JSFX, for instance. Not last time I checked, at least. Maybe things have changed. Oh, not trying to badmouth Python in general. No, I don't think you were trying to. I don't think you were trying to. Don't get me wrong. It's just something that I'm saying because I hear that a lot. Not about Python or C++, but I hear comments like, "Oh, programming language X is bad," or people who use programming language Y are not as good programmers. And I hear that a lot, especially because I was in the programming language theory group of people when I was in academia, and I heard that a lot. So it became a pet peeve of mine. For instance, when someone says, if you want the speed of X, could you also just use X? Sometimes, yes, that's true, but there is more than just the technicality. If you may want the speed of X, but you want to continue using the tools you know and talking to the people you know from language Y. So that could be why you would try to shoehorn some things. And it may be a gimmick, and you're trying to mimic the behavior of the other thing. But I was speaking to this thought of perhaps there is a reason for you to do that. But people shouldn't think they can shortcut audio development by using a language that does more in shorter amounts of lines. There's more to it. Yeah, I understand. Sometimes you do need to have no garbage collector and take your or take control over allocation, take control over like you need to take control over the instructions that the processor will run if you're doing something like SIMD. So yeah, C++ is great for the things that C++ is used for. Python is great for the things that Python tends to be used for. And JavaScript tends to be good for many things that I'm interested in. If JavaScript becomes a bottleneck on the browser, WASM, is that how you pronounce this? Written in Rust is really fast, and it is just called from the JavaScript. Yeah. And you can produce this with C++, you can produce this with any language, and it is pretty fast. But it's like 1 or 2 orders of magnitude slower than writing something in C++, for instance. You were right about computation, but have you asked yourself why people prototype in Python before C++? Because it gives results faster. You can see your emulation. Yeah, that's a good point. That's true. You can run some offline processing in Python and graph it out or render a wave. Anyway, you don't want to disturb the actual topic, just want to explore the stream. Yeah, the stream is about tangents. That's why we are here for. We are here to have these sorts of conversations. Otherwise, I would write code with the camera off. you're not disturbing anything. That's what I'm saying. You're more than welcome to have these conversations. That's what we're here for. But yeah, I understand why people use Python. I also understand why people use C++. Anything can be faster than anything. I can write the slowest Rust program. Don't challenge me. I can write very slow Rust programs. I can be that bad. Right. So it seems like I explored the whole thing I wanted to explore. It seems like everything is working. Oh my God, I cannot believe it. So with that, I think we are free. We are free from this nightmare, this hell that was dealing with parameters. I think that everything is working. I don't think there are any race conditions or anything. So with that, here is the schedule. Tomorrow, I will be a guest over IDDQD Sound, the YouTube channel. Arya, you know him. You all know and like Arya. I will be with Arya tomorrow on his channel, and we will be finishing the song that we started 2 streams ago. It is an experimental song. It's wacky. We'll be finishing that. We will be trying to do a video for that as well. That will be a YouTube short, and we'll be doing data moshing. At least that's the plan. Have never worked with that. Have never played with data moshing. Looking forward to it. And on Monday, I will be working on Kill the Newsletter. So JavaScript, TypeScript for that matter. We'll be working on Kill the Newsletter, which is this web application that I maintain. And then on Tuesday, we'll be back to JSFX. And the plan will be to take these parameters that we now know how to do, apply that to the Automixer, and continue with the user interface for the Automixer. So right now, the Automixer does not have anything in the way of sliders like this. And we will add that to the Automixer. And then we will be able to hide these sliders and start. The Automixer will start to take shape on Tuesday. So see you tomorrow over at IDQD Sound. Then here on Monday for some JavaScript and Kill the Newsletter stuff. And then on Tuesday, more JSFX Automixer. Good stream. Thanks. Thanks for joining me. Thanks for being part of the conversation. It's always good when there are no finite state machines or lambda calculus. Lambda calculus? I don't know what you're talking about. Do you not like lambda calculus? Do you not like the lambda calculus? Come on. That's the greatest thing. I love it. I really love it. I even like languages that sort of resemble the lambda calculus when written out, like Lisp. Love it. The Y Combinator is just brilliant. It's what got me into programming language theory in the first place. I thought you were ready, Jeff. Nice to see. Okay. All right. So, yeah, let's get out of here. I see you tomorrow. Have a good one. Bye. Thanks for stopping by. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.